Good morning. You are going to need your Swan math book and your math notebook. So take out both of those books right now, place them on your desk. We're going to continue with division. Yesterday, you had an introduction to division. Today, we're going to go a little bit further and we're going to learn about two different methods to use when dividing whole numbers. Just as a review, let's look at the parts of division that you looked at yesterday. So when I write a division example, or when I'm given a division problem, the larger number, or the number that I'm looking at first, is the dividend, and the dividend is divided by the divisor. The answer is the quotient. And if the divisor does not go into the dividend equally, there will be a remainder. Looking at the way this problem is written, here I have my division symbol. The 11, the dividend is inside the division symbol. I am looking for how many equal groups of 2 will fit into 11. 5 is the quotient, or there are 5 equal groups of 2 that fit into 11. When you multiply back, you have 10. 5 times 2 is 10. Subtract, you have a remainder of 1. So 11 divided by 2 equals 5 equal groups with a remainder of 1. So now we're taking a look at the what, the why, and the how. What? We're using 2 different strategies for dividing whole numbers. Why? Well, division is a very important concept in math. Seeing it done, that should be done in more ways than one, can enable everyone to find a method that works for them. Let me fix this right here. Okay, so it's not going to let me fix it. So we'll just know that says done. And how? We're going to create a toolkit. When using the area model, you're going to use the 4 steps for division when using the standard algorithm. And we'll see what that looks like in just a moment. Now, I am looking at this example here, and dividend, divisor, quotient. I want you to write this example of division in your math notebook, and then you're going to label the parts. Pause the video here, write this example in your math notebook, and then label the dividend, the divisor, and the quotient. Start the video back up again when everyone has finished. So you have this copied down, and dividend, you should have 345 as the dividend. Divisor, the number of equal groups of 5 that you're looking for in 345. And quotient is the answer. So 345 divided by 5 gives you 69 equal groups of 5. Now, input model. In your math notebook, I want you to write down input model, and I want you to show the example, 28 divided by 2. Write the steps, divide, multiply back, subtract, bring down, and then show the area model and the toolkit. You're copying both of these examples in your math notebook. Pause the video here. Check to make sure everyone has copied this in their notebook, and then restart the video. Okay, so I'm going to use the area model first. And I have 2 times 1 equals 2. Again, I'm looking for equal groups of 2, so I'm writing the factors of 2. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and then the next number I want to include is 2 times 10 is 20. So when I'm using the area model, I have my toolkit here. I'm going to look for the number closest to 28 without going over, and that would be 20. So I'm going to put 20 under the 28, and this stands for 10 equal groups of 2. I'm going to subtract 8. 2 from 2 is 0. So now I'm going to look at my toolkit, and I'm going to look for the factor or the factors that equal 8. And I can see that 2 times 4 equals 8. So 2 times 4, I'm going to put the 4 on the outside, equals 8. 4 times 2 is 8. Subtract 0. Now, I'm going to add up my 2 partial quotients. 10 and 4 is going to give me 14. So I can write my final quotient above the 28. So this is using the area model and a toolkit. And you're looking for the largest factor. In this first time, it was 10. 2 times 10 is 20. You write the factor outside of the division and the product inside, subtract, and then do the same thing again. Well, now let's see how the area model differs from the standard algorithm. I have 4 steps for division. I'm going to start by dividing, then I'm going to multiply back, I'm going to subtract, and I'm going to bring down. I have 1 number in my divisor, so I'm going to look at the first number in my dividend. 2 goes into 2 1 time. That's the division. Now I'm going to multiply back. 1 times 2 is 2. Since I divided into the first number, when I multiply back, my answer goes right under the 2. After I multiply back, I subtract. 2 subtract 2 is 0. And I'm also going to compare. This number should be smaller than 2. 0 is definitely smaller than 2. I'm going to bring down my next number. And I'm going to bring down the 8. Notice when I bring down the 8, I write it right alongside the 0. And now I begin my steps all over again. I'm going to start with division. 2 goes into 8, or 2 times what number equals 8? Well, that would be 4. I divided. Now I'm going to multiply back. 4 times 2 is 8. After I multiply back, I subtract. 8 subtract 8 is 0. Compare, 0 is less than 2. I don't have anything left to bring down, so I have my final answer. And notice, using both the area model with the toolkit and the standard algorithm, I get the same answer. I get 14. So let's take a look at a second input model. And again, you are writing all of this in your math notebook. So I want you to copy down this division problem, this division problem, and your toolkit. I also want you to show the steps for division by the first problem that you write down. So pause the video here and restart the video after everyone has copied down both of these examples. Okay, so again, I'm going to start with the toolkit. And I'm going to look at, I have 924 as my dividend. I'm looking for equal groups of 3. 3 is my divisor. So I'm going to use factors of 3 to help me find the largest number that will go into 924. So I have 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. Then I'm going to jump down to 3 times 8 is 24. I can see that I'm going to have a 24 here. So I think this would be an important factors and product to write down. Well, I'm looking at this number is in the hundreds. So I think I'm going to need a product that's going to be in the hundreds also. So I'm going to go back to 3 times 1. Well, now I'm going to multiply 3 times 100, and that's 300. 3 times 200, well, that's 600. 3 times 300, that's 900. Remember, I want to find a product that's as close to 924 as I can get. And that would be 3 times 300. And that's going to be 900. So my partial quotient is 300. And 3 times 300, 900. Here, I'm going to subtract. And when I subtract, I have 24. So now I'm going to go back to my toolkit. And do I have a product of 24? And yes, I do. And that's 3 times 8. So I can put a partial quotient of 8. And the product of 3 times 8 is 24. Subtract, and I have 0. So now I'm going to add my 2 partial quotients together, and I have 308. So now let's check and see if I use the standard algorithm of divide, multiply back, subtract, bring down, if I get the same answer that I have here. So again, I look at my dividend and I have 924. I look at my divisor and I want to know how many equal groups of 3 will fit into 924. I have one number in my divisor, so I look at the first number in my dividend. 3 will go into 9 3 times. So I'm going to put a 3 in the quotient. I just divided. Next, I'm going to multiply back. Okay, and I'm going to put a little multiplication sign here to remind me that when I multiply back, I'm multiplying the number in my quotient by my divisor. 3 times 3 is 9. After I multiply back, I subtract. 9 subtract 9 is 0. After I subtract, I bring down the next number. I bring down the 2. I'm going to write the 2 right next to the 0. Now that I've completed my 4 steps, I come back to the first one and I divide. How many equal groups of 3 will fit in 2? Well, that would be none. So I'm going to put a 0 in the quotient. Once I start my cycle, I have to finish it. So I divide it. I'm going to multiply back. 0 times 3 is 0. Then I subtract. 2 subtract 0 is 2. My last step is I bring down, and I'm going to bring down the 4. How many equal groups of 3 will fit into 24? Or I'm going to think 3 times what number is 24? Well, that would be 8. Once I divide, then again, I multiply back. 8 times 3 is 24. Subtract 24, subtract 24 is 0. There's nothing left to bring down. 3 will not go into 0. So I am finished. And notice again, I get the same answer. There are 308 equal groups of 3 in 924. So now we're going to move on to structured guided practice. You now need your SWAN math book, and you're going to open up to, it should be page 50. You can keep your math notebook on your desk, but now all of the work you're going to be doing in your SWAN math book under structured guided practice. This way you have examples in both your math notebook and in your SWAN math book under structured guided practice. So I want you to copy down the steps for division under the example given here. And then you have a lot of workspace here. I want you to rewrite this using the area model and write your toolkit. Pause the video here until everyone has completed this step. Okay? Again, we're going to start with the area model and the toolkit first. I want to know how many equal groups of 4 will fit into 148. So again, I'm going to write my multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Then I'm going to jump down to 4 times 6 is 24. And 4 times 7 is 28. I think I'm going to need those two. I don't have to put the 4 and the 5 because I'm probably not going to need those products. But I'm noticing that this is 148. So I know I'm going to need numbers that are going to be at least some of them in the hundreds. So 4 times 10 is 40. 4 times 20 is 80. 4 times 30 is 120. So if I have 148, I want to find the largest product in my toolkit that will be as close to 148 without going over. And that would be 120. So my partial quotient is going to be 30. 4 times 30 is 120. So I'm going to write that under the 148. I'm going to subtract. 8 from 0 is 8. 4 subtract 2 is 2. And I'm going to look at my toolkit. And again, I want to find a number as close to 28 without going over. And I have 4 times 7 is 28. Well, 4 is the number that I'm dividing by. 4 times 7, 7 is going to be my partial quotient. And 4 times 7 is 28. So I'm going to write this under the 28 that I have here. Subtract 0. And when I combine my partial quotients, 30 and 7 is 37. So let's see how that works on this side using the structured guided practice. I have 4. Well, 4 won't go into 1, but 4 will go into 14. I'm going to think 4 times 3 is 12. 4 times 4 is 16. 16 is too large. So this is going to be 3 times. So I divided. 3 times 4 is 12. Subtract. 4 subtract 2 is 2. After I subtract, I'm going to bring down. And I'm going to bring down the 8. How many equal groups of 4 will fit into 28? Well, 4 times 7 is 28. So I can put 7 in the quotient. Then I'm going to multiply back. 7 times 4 is 28. 0. I have nothing left to bring down. 4 won't go into 0. So my quotient for both examples is 37. So there are 37 equal groups of 4 in 148. Now, I'm going to have you work on the next structured guided practice. I want you to write your steps, show the area model and the toolkit on your page. Pause the video here, and I want you to work with the person or people that you're sitting next to. Follow the steps that we just used. Use the examples in your math notebook or look at the previous example in structured guided practice and work these out. Okay? Stop the video here. Start it up again when everyone has finished. Okay, so I'm going to look at 955, and I want to find out how many equal groups of 5 are going to fit into 955. So I have my toolkit here. The largest number that I have is 500. And 5 times 100 is 500. So my partial quotient is 100. 5 times 100 is 500. I'm going to subtract. Nine subtract 5 is 4. Okay, and I'm going to look at my toolkit. I have 455, and I have 5 times 2 is 10. Well, it's going to take me a lot of dividing to do that. And then I have 5 times 11 is 55. So I could use that. And I'm also going to think if I have 5 times 90, five times 90 would be 450. So you can always add to your toolkit if you think, that might help me out a little bit. Okay, so I have 455. 5 times 90 is 450. That's pretty close to this. So my partial quotient is 90. Five times 90 is 450. And I have a remainder of 5. Well, in my toolkit, 5 times 1 is 5. So I have a partial quotient of 1. 1 times 5 is 5. Subtract 0. I'm going to add my partial quotients. And I have 191 in my quotient. So now let's check and see how the standard algorithm is going to work. I have one number in my divisor, so I'm going to look at my dividend, and 5 will go into 9. 5 goes into 9 one time. 1 times 5 is 5. Subtract 9. I'm going to remember to put a multiplication sign here. 9 subtract 5 is 4. After I subtract, I bring down the next number. After I bring down, if I still have numbers here, I go back up to my first step and I divide. 5 goes into 45, or I'm going to think 5 times what number is 45? Well, 5 times 9. So after I divide, I multiply back. 9 times 5 is 45. After I multiply back, I subtract. And I have 0. 0 is less than 5. I'm going to bring down my last number. And I'm going to bring down a 5. And 5 will go into 5 one time. After I divide, I multiply back. 1 times 5 is 5. I'm going to subtract 0. 5 will not go into 0. There's nothing left to bring down. So I have my final quotient, 191 and 191. And the answers are the same. So whether you use the area model in the toolkit or the standard algorithm, by finding out how many equal groups of your divisor fit into the dividend, you come up with your quotient, or the number of equal groups that fit into that dividend. Okay? Let's check, or let's do the final check for understanding. We might be running out of time in class. This lesson will continue tomorrow. So if you are close to being to the end of the period right now, this is where you're going to stop the video and pause the video. And please make sure to write down either on the notes for the substitute, or somewhere where the next person who is using this lesson tomorrow will know where to begin. So leave directions for where you're leaving off. In this case, if you're stopping here, it would be the final check for understanding, and then this lesson will continue tomorrow. Okay, so pause here, and you will pick up from this point on tomorrow. Bye for now. Okay, so this is Wednesday. And again, you'll have your SWAN math book, and you are open to lesson 9. Go to the final check for understanding in lesson 9. And in the final check for understanding, you're going to write this division problem, indicate your 4 steps here. You're also going to write the area model and toolkit. So all of this needs to be copied in your SWAN math book. Pause the video here until everyone has completed these steps. Okay, well, yesterday we always started with the area model. Today we're going to start with the standard algorithm. And remember, my steps are divide, multiply back, subtract, and bring down. I put a multiplication sign here to remind me that when I put an answer in my quotient, I need to multiply back so I can continue the steps for division. So my dividend is 141. I want to know how many equal groups of 3 will fit into 141. I have one number in my divisor, but I notice the first number in my dividend is 1. 3 will not go into 1, but 3 will go into 14. So I underline the 3 and I underline the 14. And I'm going to think 3 times what number is close to 14? Well, that would be 3 times 4. So 4 goes in the quotient, Now I'm going to multiply back. 4 times 3. 4 times 3 is 12. After I multiply back, I subtract. 14 subtract 12, I have 2. After I subtract, I bring down the next number. The next number is 1, and I write it next to the 2. Now I start my cycle again. I start with division. 3 will go into 21 how many times? Well, 3 times 7 is 21. So I'm going to put a 7 in the quotient. Then I'm going to multiply back. 7 times 3 is 21. After I multiply back, I subtract. 21 subtract 21 is 0. And I have my quotient. There are 47 equal groups of 3 in 141. So now let's take a look at the area model. And again, you wrote out your multiples of 3. We also wrote out the multiples of 3 times hundreds. And when I'm looking at my number here, I have 141. So that's why I would have these in the hundreds. So I'm going to look at, and actually I think what I meant to do is put these by tens. So in what you have written, I'm going to change this. And I'm going to add one more. I'm going to add 3 times 40 is 120. Okay, so I'm looking at 141, and I'm looking at my toolkit, and I want to find a number that's close to 141 without going over. And that would be 3 times 40. So I have a partial quotient of 40. 3 times 40 is 120. Notice I'm still dividing, multiplying back, subtracting, but I'm using larger numbers when I do this. So 3 times 40 is 120. I'm going to subtract. 4 subtract 2 is 2. I'm going to look at my toolkit. And 3 times what number is close to 21 without going over? That would be 3 times 7. So I have a partial quotient of 7. And then 7 times 3 is 21. Subtract 0. When I add my partial quotients, 40 and 7 is 47. And again, I have the same quotient. Whether I use the standard algorithm or whether I use the area model in toolkit. So now, final check for understanding. Second example, write down your steps, copy everything you see here, and you're going to complete this on your own. After everyone is done, Check back in to see how you did. Pause the video here. Start it again when everyone has finished. So again, I'm going to start with 812 divided by 2. And I have one digit in my divisor. So I'm going to look at the first digit in my dividend. 2 will go into 8 4 times. So I put 4 in the quotient. After I divide, I multiply back. 4 times 2 is 8. After I multiply back, I subtract. 8 subtract 8 is 0. I'm going to erase this here so it doesn't look like either a subtraction sign or something else. And I subtracted. 8 subtract 8 is 0. I'm going to bring down the next number. I bring down the 1. 2 will not go into 1. So I put a 0 in the quotient. I multiply back. 0 times 2 is 0. After I multiply back, I subtract. 1 subtract 0 is 1. You don't need to bring this 0 down. I'm going to cross that out. And we have 1. After I subtract, I bring down my next number. Okay, and I bring down the 2. I write the 2 alongside the 1, and I go back to my first step. How many groups of 2 will fit into 12? Well, there will be 6 groups of 2 in 12. Then I multiply back. 6 times 2 is 12. Subtract 0. 2 will not go into 0. There's nothing else to bring down. So I have my quotient, 406. Or there are 406 equal groups of 2 in 812. So now let's take a look at the area model. Again, I've got a dividend of 812, a divisor of 2. I've written my multiples of 2, and then I've written my multiples of 2 times hundreds. So I'm going to look at my dividend of 812, and I'm going to look to see which factors I can find that will be the closest to 812 without going over. And that would be 2 times 400. 2 times 400 is 800. That's very close to 812. So I'm going to put 400 as a partial product. 400 times 2 is 800. I put the 800 under my dividend. Subtract. And I have 12. Well, now I'm going to look for a product that's as close to 12 as I can get without going over. And I have exactly 12. 2 times 6 is 12. So I have a partial quotient of 6. 2 times 6 is 12. So I'm going to write 12 under the 12 here. Subtract 0. I'm going to add my partial quotients together. And I have 406. And again, my quotients are exactly the same. So now we're going to go on to student practice. And I want you to use either method that you have practiced here to complete 1 and 2. Pause the video here and complete both examples. Okay, so let's check and see how you did. So again, I've got my toolkit for the area model. And I have 836 divided by 2. So I want to know how many equal groups of 2 will fit into 836. So I'm going to look at my toolkit, and I'm going to look for the largest product to help me find my partial quotient. And I notice that 2 times 400 is 800. That's very close to 836. So I'm going to put 400 as my partial quotient, and 400 times 2 is 800. I'm going to subtract that from my dividend, and I'm going to be left with 36. So now I'm going to look at my products to help me find a partial quotient, and I want to get as close to 36 as I can without going over. And I notice that 2 times 18 is 36. So I have a partial quotient of 18. And 18 times 2 is 36. Subtract 0. I'm going to add my partial quotients together. And I have 418. So now I'm going to use the standard algorithm. And again, my 4 steps are divide, multiply back, subtract, and bring down. I'm going to put my little multiplication sign there to remind me that I'm multiplying back here. And I'm going to look at my divisor, and I have 1 digit. I have 2. So I'm going to look at the first digit in my dividend. And 2 will go into 8 4 times. Multiply back. 4 times 2 is 8. Subtract. 8 subtract 8 is 0. After I subtract, I bring down. And I'm going to write the 3 next to the 0. Once I finish those steps, I go back to the first step again. And I divide. 2 will go into 3 1 time. 1 times 2, multiplying back, is 2. After I multiply back, I subtract. 3 subtract 2 is 1. And I bring down the next number. I bring down the 6, and I write the 6 next to the 1. So now I need to start my steps all over again. And I'm going to divide 2 into 16, and that's going to go 8 times. 8 times 2 is 16. Subtract 0. And my quotient, 418. 418. So there are 418 equal groups of 2 in 836. So now I'm looking at 42 divided by 7. Well, I'm not going to do a toolkit for this one. I'm going to think of my 7 table. 7 times what number is 42? 7 times 6. And I'm still using my steps of divide, multiply back, subtract, and bring down. So I divided. 7 goes into 42 6 times. I'm going to multiply back. 6 times 7 is 42. I'm going to subtract 0. Well, there's nothing left to bring down, so I have my quotient. There are 6 equal groups of 7 in 42. Continuing with student practice, I want you to complete this one. Again, using either method. Pause the video here until everyone has completed number 3, and then start the video back up again. Okay, so now let's take a look at what your answer is for 105 divided by 5. Well, I'm going to take a look at using the standard algorithm first. And again, I'm going to write my steps. Divide, multiply back, subtract, and bring down. And I have 1 digit in my divisor. So I'm going to look at the first digit in my dividend. And I realize 5 will not go into 1. However, 5 will go into 10. And 5 will go into 10 2 times. So I put the 2 in the quotient. I write the 2 over the 0 because I'm dividing 5 into 10. So 2 goes over the 0. Then I'm going to multiply back. 2 times 5 is 10. After I multiply back, I subtract. 10 subtract 10 is 0. After I subtract, I bring down. I bring down the 5, and I write the 5 next to the 0. Well, I'm going to go back to my first step, and I'm going to divide. 5 goes into 5 1 time. Multiply back. 1 times 5 is 5. Subtract. 5 subtract 5 is 0. Well, there's nothing left to bring down, so I have my quotient of 21. So taking a look at the area model in the toolkit, I have my toolkit written here. I want to find a product as close to 105 as I can without going over. And the closest I can get is 5 times 20, which is 100. So I'm going to put 20 as a partial quotient. 5 times 20 is 100. I'm going to subtract that from my dividend of 105. And I have a remainder of 5. I don't have anything left to bring down, but 5 will go into 5. 5 goes into 5 1 time. 1 times 5 is 5. 0. Okay. So I'm going to add my partial quotients together. And again, I get 21 using either method. I get the same answer. So now I want you to try number 4. You can use either method. Pause the video here, and you are going to start the video back up when everyone has finished number 4. Okay, so let's start with the standard algorithm. And I'm going to look at 3 in my divisor. And in my dividend of 366, I realize that 3 will go into 3 one time. So I divided. Now I'm going to multiply back. 1 times 3 is 3. Subtract 0. Bring down the 6. Write the 6 next to the 0. And now I start my steps again. I'm going to divide. 3 will go into 6 2 times. 2 times 3, I multiply back. 2 times 3 is 6. After I multiply back, I subtract. 6 subtract 6 is 0. Bring down the next number. I bring down another 6. And 3 will go into 6 2 times. Multiply back. 2 times 3 is 6. Subtract 0. There's nothing left to bring down, so I have my quotient of 122. Well, now let's look at the area model. And I want to find the closest product to 366 that I can find. Well, I've got 300 here. 3 times 100 is 300. So I have a partial quotient of 100. 3 times 100 is 300. So I'm going to subtract. And I have a remainder of 66. So I'm going to look at my toolkit again. I want to find a product as close to 66 as I can get without going over. And I have 3 times 20. So I'm going to put 20 as a partial product. And 3 times 20 is 60. I'm going to subtract, and I have a remainder of 6. 3 will go into 6 2 times. So I have a partial quotient of 2. 2 times 3 is 6. Subtract 0. So I'm going to add my partial quotients, and I have 122. Again, the exact same quotient. Whichever way makes more sense to you, that's the way that you should use for dividing. So we have 2 more examples. And I want you to pause the video here. I want everyone to complete these 2 examples and then restart the video when everyone is done. You have a number of models to look at in your Swan Math book, and you also have examples in your math notebook. You can work together or you can work alone, but see if you can get these completed. Pause the video and start back in when you're done. Okay, so let's take a look at the standard algorithm first. And I have 5 in my divisor. So I'm going to look at the first number in my dividend, and I realize 5 is not going to go into 4. 5 will go into 48. And the closest I can get is 5 times 9. 5 times 9 is 45. So I divided, and then I multiplied back. After I multiply back, I subtract. 8 subtract 5 is 3. Bring down the 5. 5 will go into 35 7 times. 7 times 5 is 35. Subtract 0. Nothing left to bring down, so I have my quotient. Now let's take a look at the toolkit. I want to find a product as close to 485 as I can without going over. So looking at my toolkit, 5 times, this should be 90, that should be 70. 5 times 90 is 450. So I have a partial product of 90. And 5 times 90 is 450. So I write that under my dividend and subtract. And I have 35. Well, looking at my toolkit, 5 times 7 is 35. So I have a partial quotient of 7. 5 times 7 is 35. Subtract 0. I'm going to add my partial quotients together, and I have 97. So now for this last one, I'm going to rewrite this. Okay, and I'm going to use the standard algorithm. Divide, multiply back, subtract, bring down. So I'm going to look at 6 and 9. 6 will go into 9 one time. 1 times 6 is 6. Subtract 3. Bring down the 0. 6 will go into 30 5 times. 5 times 6 is 30. And I am left with 0. And I have a quotient of 15. Now, go to page 55 in your Swan Math book. Follow the prompt below and write your answer in the space provided on page 55. And the prompt is choose a problem from student practice, any of the 6 that we just worked on, and write a paragraph explaining how you solved the problem and how you can check your work. Okay? So pause the video here, and everyone is going to page 55, and you're writing your explanation in your Swan Math book. Okay? Good job.